Good evening to all of you. Today we'll start elevation of boiling point. So before you going to boiling point, first you have to know that what is boiling temperature. Boiling temperature or boiling point is the constant temperature at which liquid start boil, means it's converted to vapor phase, and throughout this boiling process the temperature remains constant, and a liquid start boiling only when vapor pressure reach 1 atmosphere. Now over here AB and CD there is two curve, where AB indicates curve of pure solvent and CD indicates curve of solution, a graph or line of solution. Why AB curve is higher than CD curve? Because we know that when a non-volatile non-electrolyte solute is added to a solvent, then the upper surface area is covered by the solid particles. That is why the effective surface area decreases, and for this reason corresponding vapor pressure is also decreases. So that's why AB curve is higher than that of CD. Now 1 atmosphere line cut AB curve and CD curve at the point P and Q, and the temperature corresponding to point P is boiling temperature of the solvent, pure solvent. It is indicated by TB, and the boiling temperature of the solution is TB prime. So graphically it is clear that the boiling point is elevated. Boiling point of the solution is higher than that of solution. That is called delta TB, or elevation of boiling point. Now this delta TB equal to boiling point of the boiling point of the solution minus boiling point of the solvent. Now according to Clausius-Clapeyron equation, we know that elevation of boiling point is directly proportional to the molality of the solution. So delta TB, that is elevation of boiling point, and that one is equal to molality of the solution. Now delta TB, that means elevation of boiling point, is equal to some constant should be needed, that is called proportionality constant, and over here proportionality constant is ebuloscopic constant, which is represented as KB. So delta TB equal to KB into M. So you have to remember this equation, delta TB equal to KB into M. Again, now KB equal to KB into, what is M? M is the molality. So molality means 1000 W2 by W1 M2. Clear? So we can say delta TB equal to 1000 W2 into W1 M2. Clear? Now this KB value, this KB is the property of the pure solvent or property of the solvent, because KB equal to RTB square by 1000 LV, where R is universal gas constant, TB square, TB is the boiling temperature of the pure solvent, and LV is called latent heat of vaporization of the pure solvent, and LV is enthalpy of vaporization, that means del vaporization of enthalpy by the molecular mass of the solvent. So from this data it is clear that KB is totally depends on nature of the solvent. Now this KB, now definition of KB. So we know that delta TB equal to KB into M. So KB into M. So when m equal to 1, then delta TB equal to Kb. So what can we say? We can say the elevation of boiling point, the elevation of boiling point is equal to the ebullioscopic constant when the molality of the solution is 1. Or we can say that ebullioscopic constant is equal to the elevation of the boiling point for 1 molar solution. So since colligative properties is depends on number of solute particles, so that's why if we take 1 molar different solution, if the solute is non-electrolyte and non-volatile, means if the solute does not associate or dissociate in solution, then the elevation of boiling point is same. What does it indicate? It indicates, suppose 1 molar glucose and 1 molar urea is taken. So here glucose and urea both are non-volatile non-electrolyte solute. So since their molality is same, and if both are present in water, means we prepare aqueous solution. So here if the water is the solvent, then we can say that delta TB value is same. Clear? So equimolar solution, for the equimolar different solution, delta TB value is same because it is colligative properties. But the condition is that the solute does not associate or dissociate in solution. Now the value of Kb for water, value of Kb for water. So we have Kb equal to RTB square by 1000 LV. Now R is universal gas constant. So what is its value in calorie unit? 1.987 calorie per Kelvin mole. Calorie per Kelvin mole. Boiling temperature of water is 100 degree centigrade, so that means 373 Kelvin. Its square divided by 1000 into elevation of into latent heat of vaporization. Latent heat of vaporization is 540 calorie per gram for water. 540 calorie per gram. Now what is the unit of 1000? Unit of 1000 is gram per kg, because we know that 1000 is generally dimensionless. Any number is dimensionless. So 1000 gram means 1 kg, we can say. So if we write over here gram per kg, if we take this unit for the 1000, then gram cancel, calorie cancel. Over here Kelvin mole, so 1 Kelvin and over here another Kelvin cancel. So ultimately it becomes, that unit of Kb becomes, first is value is 0.52 kg Kelvin per mole. Kg Kelvin per mole. Okay.